So lesson 49 is on displacement versus distance and speed versus velocity. So basically, I've told you guys this before. Displacement and distance are not the same thing. Okay. So if I talk about my cross country team and I say we start here at the school, we run out 3.5 miles, we turn around and come back 3.5 miles. We've gone a total distance of 7 miles, but the amount that we've moved from our starting position is 0. Okay. So this is a big concept in physics. I know it hurts your heart to think of not traveling 7 miles, right? It's a big concept in physics, and I think you'll understand what we're doing in calculus as well. So the big thing that I tell people is to think about a number line. So if you start at 7, so if you start 7 meters out, and over the first 2 seconds you travel 2 meters to the right, where am I now? I'm now at 9. But then if I move backwards over the next 3 seconds, I move backwards 10. I'm now at -1, right? So we're just kind of piecing everything together and doing one thing at a time. And we're thinking where we're located after that time. All right, so number 1. So it says, if an object moves along a straight line with velocity v of t equal to t cubed plus 3t squared, find the distance traveled between t equals 1 and t equals 4. So in order to find the distance, right, which is kind of like a position, you're integrating the velocity function. Okay, but since it's distance, any negative velocity we have, we want to make it a positive, right? So we end up integrating for distance. We find the integral of the velocity function in absolute values. Okay, so if I'm finding it from 1 to 4, that's what I'm doing. So if I was asked to find this by hand, I would have to find the x-intercepts, or t-intercepts in this case. So I would pull out the common factor, which is t squared. I'd have a t plus 3 left. So I'd get t equals 0 and t equals -3. So at 0 and -3, I have t-intercepts, x-intercepts. And it's a t cubed shape, right, x cubed. So x cubed usually looks like this, right? In this case, do you guys see how it's t squared is equal to 0? Do you guys remember all this from algebra 2? There's something called multiplicity. So what's happening? It's going up, it's coming down, and it's going to bounce off that 0 exactly. So when you zoom in this particular area, it looks like an x squared curve. So it hits 0 twice. Yeah.
Yeah, when you pull out t squared, why do you still have a t in the t plus 3?
Because this was a t cubed. It's just my handwriting's messy. So that should be t cubed there. All right, does this make sense? Okay, so now if we're trying to find the area from 1 to 4, was that part above the axis anyway? Yeah, so really do I need absolute values? No. V of t is positive on 1 to 4 anyway. So I don't have to worry about that absolute value in this case. So I just say, okay, I'm going to integrate this velocity function t cubed plus 3t squared. And you guys would know how to do that by hand. So you'd say 1/4 t to the 4th plus t cubed going from 1 to 4. And you'd get some number out. I don't know. You guys have your calculators out. I got to search for mine apparently. Let people borrow them. 256 divided by 4, 64 plus 64, 128. Minus 1, 127, minus 1/4. 126.25, is that what you guys got? Look at those mental math skills.
Wait.
All right. So someday, guys, with practice, you can do all that in your head, I promise. All right. So that's going to be the distance. Now, in this case, is it the same as displacement? So displacement is not taking the absolute value. So yeah, distance and displacement are actually the same thing in this case. Because all of it was above the axis anyway, we didn't have a velocity where it was negative. Okay, so we're not worried about, turning around, turning backwards and going forwards and turning backwards. We're only going in one direction.
Wait, why is it 0.25?
Oh, did I say 0.25? I think in my head I said that, but You get a bonus point. All right, next up. So number 2, a particle moves along the x-axis with a velocity of 6t squared minus 18t plus 12. So I don't know, does this one have a negative velocity at any point on 0 to 4? So we got to figure that out. So this is a parabola, and we're going to graph it. We're going to find where it's crossing the x-axis. You don't think it goes backwards? We'll see. So I factor, I think it does. So I get t minus 2 and t minus 1. So I get t equals 2 and t equals 1. So good. So it's between 1 and 2. The y-intercept's 12 way up there. And then we have this parabola. So if we're between 0 and 4 and we were supposed to do this by hand, it gets to be a little complicated. Because we have from 0 to 1, and then what happens? This part flips over the axis, right? So we have from 1 to 2. And then we have from 2 to 4. Yeah, we do. Cole's realizing what we have to do, or the rest of you realizing what we have to do. So if I'm finding the total distance,
I think I like displacement better.
yeah, you do. It's not fun.
Is there a shortcut you're going to teach us?
I mean, I'm going to show you how to do it on the calculator. That's a shortcut, right? So what happens is you have to think about the part that was below the axis. So in this case, we were below the axis from 1 to 2. So we want to flip that velocity function over. So what am I doing to the velocity function in order to flip it over? I'm making it the opposite, right? So I'm getting rid of the absolute, or I'm taking the absolute value, which makes it, instead of a negative number, I make it a positive. So the way that I'm going to write that is I'm going to say I have my positive version of v of t from 0 to 1. That was positive anyway. But then I had negative numbers from 1 to 2. So I want to integrate negative v of t, right? Because negative numbers become positive numbers. And then I'm going to integrate 2 to 4 of v of t. And it gets a little bit messy because you have 0 to 1, and you got to integrate this 6t squared minus 18t plus 12. Right? And then you have the 1 to 2, and you got to integrate negative 6t squared plus 18t minus 12. And so on. All right, I'm guessing you don't want to do that. All right, we'll use our calculator. Actually, on your homework, I do let you use your calculator because I'm so nice. The easiest way to do this is under y1, put in your function. Now, I usually recommend to put it in under y1 because a lot of times in like free response questions, you have to graph things anyway. And you have to find intersection points and so on. So like if you were graphing this and you didn't know the x-intercepts, you would graph it and then you would do second trace 0, right, to find those x-intercepts. So we could do that. And if they weren't nice numbers, you could store them. You might have to do that on your homework, right, storing values. So then you go back to your main screen and we want to integrate the absolute value. So go ahead and get your calculators out. Try it along with me. So we're going to do math 9. And I want to integrate the absolute value of what I put in for y1. So absolute value I get by hitting math, going over to NUM number, an absolute value. And do you guys remember how to get y1? We do vars, y-vars, function y1. So anytime we want to pull what we've already typed in somewhere else, we can do that. And we want our x values to go from 0 to 4. So I'm doing the absolute value of the y1 function from 0 to 4, and I hit enter. And so my answer should be 34. So all of this will end up equaling 34. Okay. So let's think about this. The displacement, is it going to be equal to 34? Is it going to be more than 34? Or is it going to be less than 34?
Wait, what did you, can you show your calculator?
Yeah, the x, did you do your x comma? Do you have it set up like this, or do you have the newer kind?
No, I have it set up like that. I didn't put the parentheses after the one.
That shouldn't matter, but I'm guessing the x probably does. Well, I don't know. Maybe the parentheses does
it
matter.
was the-
Yeah.
Apparently it was absolute
Yeah.
value.
Yeah, I guess you have to tell that where to
We're at
end.
29.
Did you add them together? Did you just do the...
So I did absolute value of y1 going from 0 to 4. And under my function,
Oh, it's 0 to 4. I did 1 to 4. Did you do 1 to 4? No way.
you guys both did 1 to 4. That's
Yeah.
funny. All right, so we get 34. So our next question. So the displacement. Now displacement, there's no absolute value, right? We're going from 0 to 4, and we just have v of t dt. Is this number going to be more than 34, less than 34, greater than 34, and why?
Less than 34.
Less than. Why do you think less than?
Because you're doing the negative velocity.
Right, I'm going to have negative numbers that I'm adding in, right? Imagine these are all like rectangles. I now have rectangles that have a negative y value. So if I go to my last thing that I put in, most of you guys have calculators where you can arrow up and grab that equation. If you don't, you can always do second enter, and it pulls up the last thing you did. And we don't want the absolute value there, so we delete the absolute value, and then you're going to have to delete that parenthesis that went with it. And we end up getting 32, so it's a little bit less. All right, so same idea on number 3. Can we skip number 3? It's still a parabola. You would still find the x-intercepts. You'd find from 0 to 3. You could integrate it all without a calculator. It's just not very fun. I think that one only has 2 pieces, though, not 3. So let's go to number 5. Did I skip number 4 as well? What's number 4? Yeah, we'll skip it. Let's go to number 5. I think you guys get the idea. We've kind of done distance and displacement before. All right, so if we have this one. So I'm skipping around. All right, this time we're still trying to find.
Oh, it's number 4.
Oh, it's number 4 for you guys. So I got rid of one anyway.
Oh, gotcha.
So I'm going to do 2 sine of t plus 1 equals 0. I want to find those x-intercepts, right? Or t-intercepts. So I'm finding where sine of t is equal to -1/2. Okay, you all do know how to do this without a calculator, I promise. Okay. So we have 2 places on our unit circle. We're on the interval 0 to 2 pi. So we're going to have 7 pi over 6 and 11 pi over 6. Everybody agree with those? Here's the hard part. Some of you guys have forgotten how to graph this. So knowing where it's above the axis and where it's below the axis is a little bit tricky. You could test points. You could see if it's positive or negative values. So like on the left of 7 pi over 6, on the right of 7 pi over 6, and so on. All right, here's what I think of when I'm graphing. I always relate things to Algebra 2. Okay, my 2 main classes that I love teaching are Algebra 2 and AP Calc. They're very interconnected. All right, so if I have 2 sine of t plus 1, this is like sine of t, which we know looks like this. You guys all know sine of t. Only it's been shifted and stretched. It's been shifted up 1, so its new axis is here. It still goes out to 2 pi, but there's a vertical stretch. So that affects what we call the amplitude. Do you guys remember this from pre-calc, way back when? Okay, when I am teaching my pre-calc students, I always have them draw the min line and the max line because to me it's kind of like handwriting class when you're like in 2nd grade, which my son is seriously struggling with. And you're staying between those lines. So here's where we're starting. We're starting on the equilibrium line, and we go up, we go down through the equilibrium line, we go down to the min, and we go back up by the time we get to 2 pi. That's 1 full rotation of sine. Does that make sense? If it had been cosine, you guys remember it would start here, it would go down, and then it would go back up to there. Okay, that's the difference between those 2 curves. So we want to figure out where it's above the axis. What do you guys think these points are right here? 7 pi over 6 and 11 pi over 6. That's where it crossed the axis, right? So what happens is that part that was below now gets bumped up. So we're finding this area, and we're finding this area, and that itty-bitty area right there. And yeah, you could do that all by hand. I know that's a little bit challenging, but you could do it. So let's at least set it up. So our distance would be the absolute value of v of t dt going from 0 to 2 pi. And so we'd say, well, we got the 0 to the 7 pi over 6 part that's above. That's our regular velocity function. And then we got our point that's 7 pi over 6 to 11 pi over 6, and it's not our regular velocity function. They were all negative values, so we're going to multiply by -1 to make them positive values. And then we got that last part, which was 11 pi over 6 to 2 pi of the velocity function.
Why would for 7 pi over 6
I did. Well, it's not negative. It's negative of negatives, right? So these were all negative numbers, right? They were all down here. And we want to flip them over. So if I multiply a negative by a negative, I get a positive, right? That's what we're doing. We're making it a positive.
Why is there negatives?
Because these are negatives. And so when I multiply by negative, I get a positive.
Oh.
I was waiting on that light bulb. Oh, okay, gotcha. All right, so, and you could do this by hand. How do you integrate, like, 2 sine of t plus 1? It would be 2 times negative cosine of t plus t, right? And then you would go from there. Okay, so let's get it with our calculator, and then let's do the displacement as well. All right, so you don't have to do the absolute, like, put everything in under y1 if you don't want to. I don't know why this is doing this to me. Ah. Did you guys get it? Put it in. Sorry to my YouTube people. All right, should just grab my number from before. So 2 sine of x plus 1. And then we're going to go second quit, math 9. If we want to do the absolute value, we got to put that in, y1. X goes from 0 to 2 pi. So that's the easiest way without doing the 3 separate integrals, right? And sometimes it takes a while, especially when there's like sine, cosine, tangent, and an absolute value. Because basically what your calculator is doing is it's doing like an infinite sum. It's finding the width times the height of the rectangle, width times the height of the rectangle. It takes a little while. So 9.023, did you guys get that number? If you did not, check to see if you're in radian mode or not. All right, and then we want the same thing, but we want to remove the absolute value so we can get the displacement. So then you go in, you can do second enter, and just get rid of that absolute value. And you get 6.283. Do you guys think that's 2 pi? Let's see. Looks like 2 pi to me. All right, make sense? Okay, so do you guys understand the difference between distance and displacement? Okay. All right, so let's look at speed versus velocity. All right, so speed and velocity are related in the same way. Like one of them is going to be the absolute value and one's not. Okay, so speed is the one that's absolute value. Velocity is the one that indicates direction. So if you see something that says negative 50 miles per hour, it means that the speed is 50 miles per hour, but you're moving in the opposite direction. You're moving backwards or down. You either do backwards or down, like left or down. So the speed is the absolute value of velocity. You will see this, the AP test asks for speed a lot. Okay. So number 7, a particle moves along a line in such a way that at time t between 1 and 8, its position is given by s of t equals the integral from 1 to t of 1 minus x times cosine of x minus natural log of x times sine of x dx. Woo-wee! Looks a little complicated, right? So A says write a formula that expresses the velocity. So how are position and velocity related? Velocity is the derivative of the position. Remember, it goes position, velocity, acceleration. So if I'm trying to take the derivative of the integral from 1 to t of 1 minus x times cosine of x minus natural log of x times sine of x dx. Whew, my hand's tired. How do I do the derivative of an integral? What's that called? It has a three-letter acronym. Is that what you call an acronym?
Oh, is it the fun one with your
FTC, right? FTC. Is that what that's called, acronym? I'm losing my English words over the years. I'm losing it.
Yeah.
All right, so I'm going to put that in for all of those things. If it had been t squared, I'd put the t squared in, but then at the very end, I'd multiply by 2t, right, by the chain. So our velocity function is going to look like 1 minus t times cosine of t minus natural log of t times sine of t, like that. No dt, right? Leave that off. So B says, at what instant, so what time, does the particle reach its maximum speed? So if I want to find its maximum speed, I need to first recognize that the speed is the absolute value of the velocity function. So how can I find that maximum of an absolute value? What if I told you you could use a calculator to help you? How would you find it? Yeah, you just graph it, right? If you're finding the maximum, we go to our graph, and we plug it all in. So I'm going to do math, number, absolute value, and I'm going to put that in. So I'm going to put 1 minus, and you don't have to do t, you can do x. That way you're not doing alpha t every single time. That would take forever. Minus natural log of x times sine of x. Did you already put that in? You're so speedy. All right, and then we hit graph. And since I have the absolute value, all of this is going to be above the axis, right? Because it's all going to be positive numbers. And so I get this curve, and it looks like that. And my window might be like out to 100 or 50 or something. And you'll see that it continues to go up and up and up and up and up. Okay? So what do you think I want to make my window? Look at the original.
1 to 8.
Yeah, 1 to 8. I want to do window 1 to 8 so I don't get distracted by all those other maximums. I don't want to be like, oh, what are those other things? So I'm going to go from 1 to 8 and only look at that portion. So I hit graph. It goes very slowly. And then I want to find the max. So I do second trace maximum. Where does it look like it is? This one or this one? Left or right? The one on the right, yeah. So I do second trace maximum, and I go over there, and I do left bound, right bound. So left bound, right bound, and then I go where I think it is. Usually if you just kind of get close to it, it's fine. 6.700. Do you guys see that? So that happened at So that's when it reached its maximum speed. Now if I ask for its maximum speed, that would be the y value that's over here. Do you guys see the 5.896? That would be the maximum speed, the y value associated with it. Okay? Next question, when is the particle moving to the left? Calculus keywords, when I see when is the particle moving to the left, what am I saying in my head? I'm saying, what's negative though? The slope meaning the velocity function?
Yes.
Yeah, our velocity is negative, right? We want when our velocity is negative. Now we graphed the speed. So what do I need to do to get the velocity? Get rid of that absolute value, right? And then I hit graph. And now I'm going to have a portion of it that goes below. So now I want to figure out where that is. Now be careful though, because when you graph this, do you guys see how it looks like? It's going to look like it's crossing right there at 8. I don't know where it's crossing. Okay? So I can find this first x-intercept. So I can do a second trace 0. And I can get on the left side and the right side. And then guess, enter. I do get a number there, 5.204. But I don't want to just put 8 there, because I'm not really sure. What if it's like 7.91? I don't know, right? So it looks a little too close to tell, so let's make our window go out to like 9, just to give us a little bit more room. And then let's find the 0 there as well. So do second trace 0. And I think you'll see that it's not actually 8. It's a little bit before 8. A smidge. Ari was saying, can I just make it 8? And I'm like, no. Because you guys need to be precise. Haven't we talked about bridges and building things? If you guys are going to be our future engineers, we can't just round throughout the problem. So 7.987.
So 8.
7.987. What if that's in miles? Makes a difference, right? All right, and D, find the total distance from 1 to 8. So if you're finding the total distance, how do I find distance? Absolute value of the velocity, integrated, right? So if my original thing was position, right, sometimes that's okay. Like if you're just finding the position, like this end position at 8 and the end position at 1 and like subtracting them. Sometimes that works out okay, but sometimes it doesn't. So do you guys know what I'm saying? Like, if I integrate from 1 to 8, my velocity function, the integral of the velocity function is the position function, going from 1 to 8. So I think on your homework you guys have ones where it's like, you could just do the ending position, final minus initial is what we say. So the position at 8 minus the position at 1, and it's fine. But if I'm trying to find the distance, sometimes that's not fine. Do you guys know what I'm saying? Like, think about the cross-country example. If I did my final position minus my initial position, I get 0, right? But I didn't go a distance of 0. I went a distance of 7 miles, right? So be careful with that. If you have absolute values, I would not do this, okay? I would actually find the answer. Like, I would find the velocity function and find the absolute value of it when you're going through there. So just be careful with things like that. All right, so anyway, so we have our velocity function. So we go back to our main screen. So we do math 9, mode. We don't have, or not mode, math, number 1. We don't have the absolute value, so we put it in. Vars, y vars, function y1. And we go from 1 to 8. Oops, x goes from 1 to 8. Are you guys getting more familiar with these things on your calculators? Maybe. Kellen, you gave me a nervous look. Did you get that? So it thinks for a while.
It does.
I know. The absolute value really throws them off. Because it's calculating the absolute value of every single height, right? And adding those all together. It takes forever. Anybody beat me yet? Still thinking? So 21.461. Is that what you got?
Wonderful thing about having like a phone.
Yeah. Is it better?
It
goes
is
faster? Cool. All right. So that's how we do this. So going back to what I was talking about with your homework. I want to show you a couple examples. So on number 1 and number 2, we have these graphs. We've done these before, right? This should all be familiar. We've done distance, displacement, stuff like that. The ones I was talking about that are a little tricky are things like this, where it says the position of the particle on a line is this. Find the distance traveled by the particle in the first 2 seconds. So what some people will do is they'll find the position at time 2, and they'll find the position at time 0, and then they'll subtract the 2. But remember, during that time, you could be going forwards and backwards and forwards and backwards and forwards and backwards, right? So if you're doing something like number 4, probably the most straightforward way for you guys to do it is to go ahead and take the velocity of it. How do I do that? The derivative. So I'd get 3t squared minus 5, and then put it in absolute values before you integrate. And then you find it from 0 to 2. That's probably the easiest way to get the distance traveled. Now, if it just said displacement, then if you integrate your position, so I know position, sometimes I use x, sometimes I use s, it depends. A lot of times when they're talking about along the x-axis, they talk about these particles moving along the x-axis, they'll use an x. So if I go from 0 to 2, if I integrate my, if I find my position at time 2, and I subtract out my position at time 0, that actually does get your displacement. And the reason is because that is equivalent to this. Do you guys see that? If I integrate velocity and back a position, that's the displacement function. Do you guys see? So be careful with distance versus displacement on your homework.